Okay, let's talk about event invites. If you've ever organized anything, you know the feeling, right?
Yeah.
That frustration. Sending the invite, then the whole rigmarole. Click add to calendar, download a file, open it, maybe get sent to another web
Oh,
page.
yeah. Fill out a form you basically just gave the info for. It's clunky.
It really is.
Huh?
And then if the time changes, you just cross your fingers. They even see the update email.
And we've all had those ghost events show up.
Exactly. The meeting canceled weeks ago, still sitting there on your calendar because the update just, I don't know, failed to sync properly.
That happens all the time.
So today, we're digging into a really fundamental question. What if that simple yes, no, maybe button, the one right there in your inbox, could actually be reliable again? This is our deep dive into the documentation for something called a Calendar Invite Server, or CIS. And our mission, really, is to figure out this messaging pipeline they've built. It sounds innovative because it uses your regular calendar, client, Google, Outlook, whatever, as the main source of truth.
And importantly, as a genuine two-way street for communication.
Two-way channel, exactly.
Yeah, what's really interesting looking at the docs is how it steps away from the usual web forms. It's built entirely on cloud-native AWS stuff.
Okay.
The whole point seems to be shifting event scheduling from this, static announcement to something dynamic, trackable, and crucially based on existing standards.
Like the IETF protocols they mentioned.
Precisely. It's about using what's already universally supported instead of trying to, build a whole new front-end system everyone has to adopt.
Right, leveraging the existing infrastructure. Okay, let's get into the plumbing then. How does an event even start its journey into this CIS system?
Well, the documentation is pretty clear. It designates the organizer's own calendar client, your Outlook, your Google Calendar, as role 1. That's the primary input.
So no new software for the organizer to learn.
That seems to be the goal. Zero change for them. They just create the event like they always do. Add attendees, time, location, hit send or save. And then behind the scenes, the magic happens. The data doesn't just go to the attendees. An exact copy of that calendar event data gets sent automatically to a specific AWS Simple email service mailbox.
SES, right?
SES, yeah. The examples used an address like create@calendarsnack.com.
Okay, so SES acts like a designated drop-off point.
Yeah.
What happens when that calendar email lands there?
That's where the AWS architecture really kicks in. There's an inbound processor that grabs that email, takes apart the calendar data, the date, time, who's invited, where it is, all of it. And it stores this as a new EBO event record inside a DynamoDB table.
DynamoDB, why that specifically, not a regular database?
Well, it comes down to speed and scale, really. This isn't about complex relationships between data points. It's highly transactional. You need super fast lookups based on a unique key.
Gotcha. P-value store.
Exactly. DynamoDB excels at that high-volume, quick retrieval, and this is crucial.
Yeah.
When the event is stored, it gets a unique ID, a UID, and that UID is tied directly to the organizer's email address. Think of that UID as the event's permanent tracking number throughout its entire life.
Right, so every update, every response ties back to that specific UID.
Precisely. It enabled all the real-time stuff.
Which must be amazing for organizers, especially with recurring events or big campaigns. The docs say they can update the event unlimited times.
That's right. And they do it just by editing the event in their own calendar and hitting save again.
No logging into a separate platform.
Nope. Change the date, update the location, maybe even add a promo link in the description. They just edit, save, and that triggers another email to the SES address.
And the system picks that up as an update.
Yep. It processes it, stores it as an update link to the original UID, keeping the history intact. Even cancellations work the same way. The data goes through, gets marked canceled, but isn't deleted.
So you have a complete audit trail, basically. No more event history getting lost or fragmented.
Exactly. Consistency is key.
Okay, that makes sense for getting the event in and keeping it updated. But here's the part that really caught my eye, especially thinking about marketing or analytics.
Yeah.
How does it actually know who responded? It bypasses web forms using something called calendar receipts.
Ah, yes. This is really the heart of that two-way channel.
Yeah.
And it's clever because it just uses the standard IETF calendar rules that already exist.
How does that work in practice?
So when the CIS sends out the actual invite to attendees, it uses AWS SS, RAW. That's important because RAW gives it really fine-grained control over the email's content, right down to the byte level.
Okay.
And embedded within that invite package is a specific standardized technical instruction. The source gave that example. Attendee, part stat needs action, role reparticipant, RSVP true.
Right, I saw that. What does that string actually do?
Think of it as a polite command embedded in the calendar language that all major clients understand. It basically tells Google Calendar or Outlook or Apple Calendar, hey, when the user clicks yes, no, or maybe for this event, please send a small confirmation receipt back to this specific web address.
Not back to the organizer's personal inbox.
Exactly. It sends an authenticated signal, a tiny piece of data, directly back to the CIS system's API endpoint. It's not like a reply email flooding the organizer.
Wow. Okay, so the RSVP, the Y, N, or M, is captured automatically, straight from the attendee's calendar client.
Correct. Which completely removes that major friction point, the redirect to a landing page and filling out a form.
That is huge. But let's talk about the value of that data. This isn't just counting heads, is it?
Oh, absolutely not. The documentation calls it a live intent signal. Think about it. RSVP data from a web form. It can be anonymous. It sits in a separate database. Maybe it's vulnerable to bots or tracking pixels, messing things up.
Right.
But when the yes or no comes directly from an authenticated calendar client, Google, Microsoft, Apple, it's a real person interacting with the invite. There's essentially zero chance of bot fraud.
So it's high-fidelity first-party data.
Exactly. Data the organizer controls directly reflecting genuine user engagement. You can trust it way more for segmentation, follow-up, understanding real interest.
That changes the game for analytics. Okay, bringing it back to the process flow. How does this clean data then drive the updates we talked about earlier?
It makes the updates smarter and less annoying for users. The logic is set up so that event updates, change of time, location, whatever, are automatically pushed out only to the people who initially received the invite and responded yes or maybe to that specific event UID.
So if I clicked no originally?
You're filtered out. You won't get the update notification cluttering your calendar or inbox for an event you already declined. It respects the user's response.
That's a massive plus. You're keeping the relevant people informed without spamming those who opted out. It creates that persistent, accurate connection directly to the attendee's calendar for the whole event lifecycle.
Precisely. Maximum accuracy, minimum noise.
But I have to ask, this sounds powerful, but also potentially complex under the hood. You've got SES, raw nuances, DynamoDB scaling, managing all these UIDs. Are we just swapping the user friction of a web form for back-end friction for the organizer? How practical is this for, say, a smaller business?
That's a really fair point. The idea, according to the documentation, is that the CIS platform abstracts away that complexity. The organizer, remember, only ever interacts with their normal calendar client.
Okay.
The heavy lifting, the SES messaging at scale, the DynamoDB transactions, is handled by the AWS native architecture. It's designed for that kind of high volume. We're talking potentially millions of events, so it is inherently scalable, assuming you stay within standard AWS usage parameters.
So the complexity is managed, but the power is there, which probably explains the target market focus.
Exactly. It seems geared towards larger organizations that really need that robust, high-throughput transactional capability.
Right. Makes sense.
Yeah.
Okay, let's pivot to the comparison the source material lays out the battle card. It directly pits the CIS approach against the old way, the Add to Calendar button plus a separate RSVP form.
Yeah, and the battle card really drives home why the traditional method causes so much frustration. Take round one, the basic RSVP action.
The first click.
Right. With CIS, it's one click, yes, no. Maybe right there in the email or calendar notification. Standard, simple, universal. The old way. Click Add to Calendar, maybe download an .ics file, open the file, hope your calendar app understands it correctly, then get redirected to a web page to fill out the form.
It's multi-step, error-prone, high friction. I instantly remember checking my calendar multiple times for a big conference because I just didn't trust the file I downloaded weeks before.
Exactly. And then you get to rounds 4 and 9 in their comparison, event updates and cancellations. This is where the traditional method just, falls apart.
Completely.
With CIS, the organizer updates their calendar, hits save. That change is automatically seamlessly pushed via that controlled SES raw pathway directly into the attendee's calendar. The system ensures the information is correct in their schedule.
Whereas the old Add to Calendar button approach, the documentation literally says non-existent for updates.
Pretty much. Your only option is to send out a brand new email blast, maybe saying, hey, remember that event? The time changed. And just hope people manually find the old entry and update it, which they often don't.
Or can't, easily. And cancellations. CIS pushes the cancellation notice directly to their calendar, removing the ghost event. Yeah. The old way leaves it lingering.
Yeah, it solves the ghost event problem directly.
Yeah.
And one more key point from the comparison round 6, cross-platform reliability.
Ah, because CIS uses those standard IETF protocols.
Exactly. It speaks a native language that Google, Outlook, Apple, etc. all understand consistently. The old way, with different buttons for different platforms and relying on .exe file handling, is just inherently less reliable across the board.
Okay, the architecture sounds solid. Let's talk utility. How is this calendar invite REST API actually used in the real world? The docs outline 4 main use cases.
Right, they show quite a bit of versatility. The first is pretty straightforward. Generating links you can put on any web page for a simple one-click add to my calendar experience, but backed by this robust system. Second, generating specific API button codes designed for email marketing platforms. They mention support for over 50 vendors, think MailChimp, Klaviyo, Constant Contact.
So you can embed a true, reliable RSVP button directly into your mass emails.
Exactly. Not just a link to a landing page, but the actual RSVP mechanism connected to the CIS backend, collecting those direct calendar receipts.
That's powerful for marketers. What's the third use case?
Transactional uses within apps. This is more machine to human. Think automated reminders pushed directly to a user's calendar for things like an invoice due date, a subscription renewal notice, maybe a scheduled maintenance window.
Trackable reminders that land right where people manage their time. I could see that being useful.
Definitely. And the fourth use case, which the documentation really uses to showcase the system's dynamic power, is building custom event sites for promoting huge schedules. The big example they dive into is for tracking the entire NFL season, all 272 games.
Okay, let's focus on that NFL example. Managing that much data seems daunting. How does the CIS approach turn a static schedule into something more dynamic for a fan?
It really starts with how they model and then enrich the data. First, they take the basic NFL schedule teams, date, kickoff time, and structure it as proper calendar native events.
Right.
But then they layer on more data. They pull in team logos automatically. They add links to streaming services where the game might be shown. And, this is cool, they can even integrate with public APIs, like ESPN's, to potentially pull in real-time stats or score updates into the calendar event itself.
Whoa. So as a fan, I don't just get a reminder, game at 1 p.m. My calendar entry could actually show the logos, maybe update if the game gets delayed, and potentially even link me to live scores, all within my Google Calendar.
That's the potential, yes. Treating the calendar event not as a static block of text, but as a dynamic data object.
So, that is impressive. How do they handle the complexities of time zones for a global audience like the NFL has?
The time zone strategy they describe is pretty smart and standard practice in robust systems. All times the start time, DT start, and end time, DTEND, are stored in the database purely as UTC seconds, Universal Time Coordinated.
Okay, why UTC?
Because it removes ambiguity. The system pushes that raw UTC time to the user's calendar client. Then the user's device, their phone, their laptop, handles the rendering. It automatically translates that UPC time into whatever local time zone the device is set to.
Ah, so the server doesn't have to worry about calculating dozens of different time zones and all the messy daylight saving time rules.
Exactly.
Okay.
It avoids DST drift, ensures accuracy for fans anywhere in the world, and massively simplifies the back-end logic. The client side does the local translation.
Clever. And this all loops back to the data aspect again, right? Tracking those calendar receipts.
Absolutely. That RSVP status, did they add the game? Did they explicitly say yes, no, maybe, or just leave it as no action? Turns that calendar entry into a season-long live intent signal.
Proprietary data for the organizer.
Totally. First-party analytics data. They can see genuine fan engagement. Are people adding games weeks in advance, only their home team? Are they interacting with the enriched data? You can segment fans based on this real behavior and tailor future communication.
All while minimizing the friction for the fan and making sure any schedule changes get pushed reliably.
That's the core value proposition. Low friction from discovery to commitment with trustworthy automatic updates, all while gathering valuable intent data.
So pulling it all together, who is this really built for? Who's the ideal user for this kind of, let's face it, sophisticated pipeline?
Based on the capabilities in the AWS Foundation, the documentation suggests 3 main groups. First, large digital marketing agencies, the ones managing big brands, complex web presences, needing scalable, reliable messaging.
Makes sense.
Second, software OEMs. Think big platform providers, maybe like SAP or Salesforce or HubSpot. They could integrate this calendar messaging pipeline into their own offerings, maybe for transactional reminders or event marketing features within their software.
Embedded capability.
Right. And third, AWS partners. System integrators or consultants who specialize in building solutions on AWS could incorporate this specific calendar stack as part of larger projects for enterprise clients.
Okay, so what's the big takeaway here for, for everyone listening? What does this all mean?
I think it means the calendar invite server, or this approach at least, tackles the huge hidden complexity of dealing with all the different calendar systems and file formats out there.
It abstracts it away.
It abstracts it away, letting organizers use the tool they already know, their standard calendar, but turning it into a much more powerful, persistent, two-way communication channel.
Yeah, it elevates a simple meeting request into something much more like an advanced tracking and communication tool.
Yeah.
It guarantees accuracy, cuts user friction, and delivers that really valuable first-party intent data.
It really does. Which leads to maybe a final thought to chew on.
Go for it.
If something as mundane, as universally used as a simple calendar invitation, can be reimagined like this, turned into a dynamic, persistent data object that tracks authenticated real-time user intent, what other standard low-friction digital tools or protocols are we maybe underutilizing right now? Where else could we be gathering proprietary high-fidelity analytics just by leveraging the systems already in place?